All right, this is all the homework that goes along with this. Here are the answers to last night's homework. You can hit pause and check it. And then today's lesson is 2 applications of the Pythagorean theorem. I really like this one. You can use the Pythagorean theorem to find the distance between 2 points in a coordinate plane. So, on that yellow packet that I gave you, this should be number 1, and it is. We're going to do the first page of this yellow packet for notes, and we will do the second page as your homework tonight. Now, find the distance between the point -3, -1, and 3, 4. So, you are going to come over to the coordinate plane, and you are going to plot these points. Sam, don't worry about that now. Don't forget, points, ordered pairs, are x, y. This is the x-axis. So, -3, -1 goes right there, and 3, 4 goes right there. Now, when I ask you to find the distance between 2 points, isn't the shortest distance between any 2 points a straight line? Well, watch what I'm going to do. What did I just create? A right triangle. And this distance right here, what letter is that in this right triangle? C. Now, can I find the lengths of these 2 lengths? Well, I certainly can because we're on a coordinate plane. Look, 1, 2, 3, 4, 5. This side is 5. 1, 2, 3, 4, 5, 6. This side is 6. I'm counting the units. So, this is A, this is B, I am looking for C. So, let's go over here. A squared plus B squared equals C squared. So, I'm going to have 5 squared plus 6 squared is C squared. 25 plus 36 equals C squared. +25 plus 36 is 61. Finish this off by taking the square root. C is approximately 7.8. So, you can find the distance between any 2 points in the coordinate plane by plotting those points. The diagonal will always be the hypotenuse. Draw your right triangle, count out the spaces. Easy enough? All right. Now, this one is a little more tricky. We're not going to do that. You don't need to do that. Now, I'm going to pause. All right. This is a 3D Pythagorean theorem. We're looking for the distance from one diagonal of a prism down the other corner, so it cuts through the middle of the box. If I cut, or if I lay a hypotenuse on the bottom of my box, a squared plus b squared equals c squared. This side is really a squared plus b squared because that's the hypotenuse. Then I draw my triangle there. My 3D Pythagorean theorem is a squared plus b squared plus c squared equals d squared. So, find the distance from one corner to the opposite. Is this the problem that's on the top of your paper? Okay, so, what side am I going to call this? A. What side am I going to call this? What side am I going to call this? And then we're looking for D. So, very similar to the Pythagorean theorem in how we work it out. So we're going to do 5 squared plus 4 squared plus 10 squared equals D squared. Let's do the math. 5 squared is 25, plus 4 squared is 16, plus 10 squared is 100. So, 25 plus 16 plus 100 is 141 equals D squared. Take the square root of both sides. D is 11.9. Approximately, I rounded. Questions? Next, same exact thing.